According to physicist Michio Kaku, the boundary between science fiction and reality is merely a question of technological maturity. Today, that statement carries new weight. The object known as 3I Atlas doesn't just challenge our models of orbital mechanics, it threatens to rewrite our understanding of what's natural in the cosmos. Why would an interstellar body be slowing down inside our solar system? What explains its impossible density, almost hollow? And above all, why is there so much silence from the space agencies that should be talking the loudest? According to Michio Kaku, the boundary between science fiction and reality is only a matter of time. For decades, the physicist has described civilizations capable of moving planets and manipulating stars, the so-called Type 2 and Type 3 on the Kardashev scale. To him, detecting an interstellar artifact under active control would mark the true beginning of the spacefaring age. And now, with 3I Atlas, that idea seems to have stepped out of theory and into the eyepiece. When the name 3I Atlas first appeared quietly across observatories, it sounded like another scientific curiosity, just one more interstellar traveler passing through, like Oumuamua in 2017 or Borisov in 2019. No alarm, just excitement. A rare chance to study matter forged between the stars, but routine quickly turned into unease. With each new calculation, the object grew less obedient to physics. Orbital tables failed, models broke down, and suddenly, a phrase once reserved for science fiction began showing up in NASA's internal notes: anomalous motion. That's where Kaku's long-standing warning resurfaces. In many interviews, he said that the first sign of extraterrestrial intelligence will not be a message, but engineering, something in motion doing what nature cannot. That, precisely, is what 3I Atlas now seems to represent to even the most conservative astronomers. The question has shifted from what is it to how is it doing this? Because if a rock the size of a city can alter its own velocity, we are facing a level of energy control that exceeds even our most advanced theoretical models. Astronomy is a patient science. Decades of observation, slow refinement, incremental truth. But with 3I Atlas, time feels compressed. Every new data point deepens the mystery. As Kaku often reminds us, the universe is a mirror. It reflects not just what we see, but who we are while looking. And that mirror may now be reflecting something unsettling. A civilization just beginning to realize that perhaps it has been under observation all along. It all began as a footnote in the nightly sky surveys, a faint moving dot flagged by the Pan-star system in Hawaii. At first, nothing remarkable. Another parabolic traveler destined to enter and exit the solar system without a trace. Routine science. But soon, routine became a luxury no one could afford. Within weeks, observatories from Chile to Arizona noticed something was off. The trajectory was shifting. Slightly, rhythmically, consistently. The deviation was so subtle it could have been calibration noise, until 3 independent telescopes confirmed the same result. Coincidence gave way to concern. Behind the scenes, NASA quietly updated its internal briefings, but inside the Jet Propulsion Laboratory, one word began appearing in reports with increasing frequency: anomaly. What should have been an inert interstellar object was showing micro-decelerations inconsistent with any gravitational model. It was slowing down, against all logic. Comparisons with past visitors were immediate. Oumuamua had accelerated mysteriously. Borisov had behaved like a textbook comet. 3I Atlas did neither. It became the third visitor and the strangest of them all, as though each interstellar arrival was raising the stakes of the cosmic riddle. Public statements remained bland, procedural. "We are refining trajectory models," NASA said. But in private astrophysics forums, the tone was shifting. Why don't the numbers fit? And why is no one talking about it openly? Curiosity was giving way to unease. When data stops fitting expectations, silence tends to fill the gap. As Michio Kaku often says, no piece of data is neutral. It always tells a story if you're willing to listen. And the story of Three-Eye Atlas was just beginning to unfold. A story that seemed to have its own script, one that no one on Earth had written. It first appeared as a blip in the radar graphs, tiny shifts in velocity, measured in thousandths of a kilometer per second. At first, they looked like noise, but the pattern repeated, precisely, predictably. Three-Eye Atlas wasn't just slowing down. It was doing so in pulses, small, deliberate, rhythmic. No natural object behaves that way. The initial explanation was simple: instrument error. Engineers recalibrated antennas, reprocessed telemetry, even repeated observations across different observatories. But the data refused to change. The deceleration remained, gentle, steady, almost intentional. When NASA's Goldstone Observatory confirmed it, the word error was permanently deleted from the reports. Physics offers no natural mechanism for what they were seeing. Solar pressure accelerates, gas jets push outward. Gravitational drag at that distance is negligible. Nothing in nature provides a break. And yet, that's exactly what the readings showed, a sustained counterforce, as if something inside the object were resisting its own motion. At JPL, internal memos began circulating, some marked Level 3 confidential. One line in bold froze everyone who read it. Observed motion inconsistent with known natural processes. That was the moment Three-Eye Atlas stopped being an astronomical curiosity and became a potential engineering event. Speculation turned technical. Could it be a magnetic field interacting with the solar wind, a self-generated plasma drag? Every theory collapsed under analysis. The pulses were too discrete, too uniform. The data suggested control, a mechanical intention behind the motion. Michio Kaku has often said, nature is elegant but never capricious. When motion repeats with precision, it's no longer chaos, it's design. If Three-Eye Atlas is truly adjusting its own speed, we may be witnessing not a rock, but a machine, one moving purposefully through the deep. And that leads to the question echoing through observatories worldwide. Who or what is at the controls? When the James Webb Space Telescope turned its gaze toward Three-Eye Atlas, what came back wasn't just light, it was disbelief. Spectroscopic data showed an average density less than 1/10 that of water. For an object tens of kilometers wide, that's physically absurd. In simple terms, Three-Eye Atlas appears hollow. The reaction among researchers was immediate. Natural bodies aren't hollow. Comets form through slow compression, layer upon layer of dust and ice built over billions of years. A hollow body shouldn't hold together, much less rotate with perfect stability. Yet Three-Eye Atlas does both, with near mathematical precision. Rotational data only deepened the mystery. Its spin rate is stable to the 10th decimal place, an accuracy that even human-built satellites struggle to maintain without active correction. No precession, no drift, no loss of momentum. Something, or someone, seems to be compensating for every tiny variation in real time. The simplest idea, an internal cavity caused by erosion, was ruled out almost instantly. There's no mass loss, no jets of gas, no visible debris. What remains is silence, symmetry, and stability, a trio more at home in engineering than in geology. Independent analyses echoed the same conclusion. Astrophysicist Avi Loeb suggested that the object might have been designed to maximize structural equilibrium. The phrase cautious but seismic spread quickly through scientific circles. Michio Kaku has long argued that the signature of intelligence is symmetry, and that's precisely what Three-Eye Atlas flaunts almost defiantly. If there's a cavity, what's inside it? Exotic matter, energy storage, a structural void for mass reduction? None of these hypotheses close the equation, but all point toward one unsettling frontier, the possibility of design. Perhaps the cosmos isn't just sending us debris. Perhaps it's sending us a device, a vessel, a probe, or a message built from geometry itself. Whatever it is, 3I Atlas may be less a visitor and more a presence. When 3I Atlas crossed the orbit of Mars, the stage was perfectly set for a breakthrough. 3 spacecraft, NASA's Mars Reconnaissance Orbiter, the ESA's Mars Express, and China's Tianwen-1 were in ideal alignment to capture history's closest recorded encounter between an interstellar object and another planet. Then, without warning, the data stopped. No alerts, no explanations, just silence. Coincidentally, a temporary government shutdown in Washington paused NASA's public communication channels at the exact same time. The ESA blamed data reprocessing delays. China offered no comment at all. To researchers, the pattern felt familiar. When phenomena defy existing models, the information tends to disappear. Sources close to several mission teams confirmed that the instruments worked flawlessly during the flyby. No malfunctions, no power failures, no transmission losses. The data exists, it just hasn't reached the public. For many scientists, that's the real alarm. It's not the first time, one European researcher said, but it's never been this total. History seems to rhyme. With Oumuamua, portions of the high-resolution spectra were classified before publication. With Borisov, raw imagery vanished from public archives for weeks. Now, with 3I Atlas, the blackout is complete. The pattern is unmistakable. The stranger, the visitor, the darker, the transparency. Michio Kaku often reminds audiences that science thrives in light, but fear survives in shadow. The agency's silence might be caution or confusion, because to admit that we don't understand what's passing through our solar system is to admit that we might not be the only engineers at work. Inside observatories, frustration is mounting. Data that could resolve the mystery is locked away, replaced by rumor and speculation. Ironically, every official silence amplifies the same suspicion that there's something they can't explain or can't say. The cosmos doesn't hold press conferences. It speaks in patterns, light, and motion. And in this case, the light has been switched off, leaving behind only one question echoing through the dark: why hide the impossible? Every simulation agreed on one thing. After passing Mars, 3I Atlas should have accelerated and vanished into deep space forever. That's what interstellar objects do. Gravity bends them, but never captures them. Yet, in the newest trajectory data from the Gemini North Observatory, something impossible emerged. The object slowed down again, and its path began to curl inward. Instead of escaping the sun's pull, 3I Atlas appeared to be surrendering to it, drifting toward a stable orbit between Mars and Jupiter. To gravitational physicists, that phrase borders on contradiction. Interstellar bodies arrive fast enough to break free. They don't simply decide to stay. Unless, of course, something is helping them lose velocity deliberately. NASA analysts dubbed it a non-explained capture. To achieve such an orbital insertion naturally would require a precise loss of kinetic energy, the kind only an engine, a magnetic field, or active propulsion could create. Yet, 3I Atlas shows no outgassing, no debris, no radiation signature consistent with thrust. If confirmed, this would mark the first interstellar object in recorded history to become gravitationally bound to our solar system. A cosmic impossibility, now turned reality. None of our models predict this, one ESA engineer admitted. It's like someone just parked an asteroid. Michio Kaku once theorized that advanced civilizations might use planetary orbits as safe observation zones. The idea once sounded speculative, until now. The region where 3I Atlas appears to settle between Mars and Jupiter is gravitationally quiet, shielded by asteroids, an ideal location for long-term surveillance. Officially, agencies avoid using the term permanent orbit, but internal simulations suggest it could remain there for decades, even centuries. That changes everything, from visitor to neighbor, from passage to presence. And so the question deepens. What if this was never a flyby at all? What if it was an arrival, and we're only just realizing that it's here to stay? With 3I Atlas apparently captured in a stable orbit, astronomers began comparing it to its predecessors, Oumuamua and Borisov. The result was as startling as it was statistically improbable. Could it be that all three, the only confirmed interstellar objects ever detected, are connected by a single pattern? Researchers from Harvard's Galileo project overlaid their trajectories. The result? Each one entered the solar system along nearly the same ecliptic inclination, within 5 degrees. That kind of alignment, by random chance, has a probability of less than 2%. 3 times in a row it borders on impossible. Each visitor also carried its own signature anomaly. Oumuamua accelerated for no known reason. Borisov contained exotic compounds never before observed in comets. And now, 3I Atlas is decelerating. Deliberately, it seems. 3 objects, 3 behaviors, 1 corridor through space. Coincidence or choreography? Opinions split fast. Some scientists believe these bodies may belong to a debris stream, fragments of an ancient interstellar structure traveling together. Others whisper about the unthinkable, a coordinated sequence, a relay of probes sent centuries apart, following the same path to map or monitor our system. Michio Kaku has long said that curiosity is universal. The desire to observe is inevitable. If intelligent life exists elsewhere, they would likely do exactly what we do: send probes first before showing themselves. Being observed, Kaku once said, would be a good sign. It means we're interesting. But optimism is giving way to unease, because unlike its predecessors, 3I Atlas isn't leaving. It's staying, watching perhaps. 3 visitors, 3 anomalies, 3 alignments. A pattern is emerging, and patterns are rarely accidents. In the quiet of space, coincidences whisper, and this one seems to be whispering the same message over and over, until someone on Earth finally listens. When NASA's Swift Observatory analyzed the ultraviolet spectrum of 3I Atlas, the team expected nothing extraordinary, just the familiar molecular lines seen in ordinary comets. Instead, they found something that shouldn't exist: a non-random emission line at 497 nanometers, pulsing at perfectly timed intervals. Every 22 minutes, the signal blinked, steady, rhythmic, and unmistakably patterned. It wasn't noise nor instrument interference. It persisted across multiple observatories and instruments. Nature rarely keeps time so precisely. Something, or someone, was modulating the light. Scientists tested every conventional explanation. Could the pulses come from jets of gas bursting at regular intervals? No. From rotational heating cycles? Unlikely. The period didn't match the object's spin. Reflection from solar flares? Impossible. The frequency was too stable, too deliberate. The official NASA statement was cautious, calling it a spectral anomaly under review. But internal notes from the Planetary Defense Coordination Office contained a phrase that spread quickly through the community: structured emission intervals. Those 3 words turned curiosity into quiet alarm. Michio Kaku has often warned that first contact will not come as a conversation, but as a pattern. And here the pattern is undeniable. Not a voice, not a picture, but a rhythm. 22 minutes apart, as if testing a channel, waiting for acknowledgement. Among scientists, debate has shifted from what to whether humanity should respond at all. Is silence still the safest form of communication, or does silence itself send a message? For now, the signal continues, unwavering, patient, mathematical. Like a clock in the dark, keeping time for something that may already know it's been heard. In recent weeks, telescopes in Chile and Hawaii began to record a faint emerald glow surrounding 3I Atlas, a diffuse green halo stretching far beyond the object itself. At first glance, scientists assumed it was the same dicarbon fluorescence seen in ordinary comets, produced when sunlight excites carbon molecules. But then came the problem. There wasn't enough carbon to explain it. Even as 3I Atlas moved farther from the sun, the glow didn't fade. Its color and intensity remained constant, defying thermal and chemical logic. The light wasn't being emitted, it was being bent. Something invisible appeared to be refracting photons around the object, as if space itself was slightly curved. That's when a radical hypothesis emerged from plasma physicists. The glow might be the visible edge of an energy containment field, a bubble of magnetized plasma stabilizing an otherwise hollow structure. If true, it would mean that what keeps 3I Atlas intact isn't its mass, but a controlled energy field. In other words, technology. Michio Kaku has theorized that a civilization capable of manipulating magnetic fields at astronomical scales would have already crossed the threshold into Type 2, the level of beings who can harness stellar energy itself. It once sounded poetic. Now, it sounds like observation. Attempts to link the glow to thermal variations failed. The pattern doesn't change with distance or rotation. Observers describe it as a standing light, a halo that shifts subtly with angle, more like a lens than a flame. Whatever the mechanism, it behaves as if the object is wrapped in an electromagnetic cocoon, holding its shape against collapse. If 3I Atlas truly is hollow, the green field may be the missing piece, the system keeping the impossible alive. And if it's artificial, it's not just protection. It's a message of capability, proof that whoever built it commands the physics we only dream of mastering. Because in the language of the cosmos, nothing says power quite like standing perfectly still, glowing in a color science can't yet explain. In the coming days, 3I Atlas will reach its closest point to the sun, the perihelion, where gravity and radiation reach their peak. For ordinary comets, this is when they accelerate violently, shedding dust and gas in luminous trails. But with this object, no one dares predict. For the scientific community, it's a moment of both anticipation and dread. At perihelion, the sunlight will be so intense that every Earth-based telescope will go blind. For almost 3 weeks, 3I Atlas will disappear behind the sun, a cosmic blackout at the very moment of maximum energy. In that darkness, anything could happen, unseen. Models suggest that if the object performs a maneuver while hidden, accelerating or changing direction, it will confirm what many already suspect: active propulsion. And propulsion means intention. When 3I Atlas re-emerges, its new trajectory could tell us whether it's simply passing by or choosing to stay. Publicly, NASA keeps its language cautious. We continue to monitor and refine models. Privately, insiders admit that the Planetary Defense Coordination Office has circulated contingency briefings normally reserved for asteroid impact scenarios. Not because the object is dangerous, but because if it remains in orbit, humanity becomes the observed. Michio Kaku has often said that the next great scientific revolution will not come from a laboratory, but from the sky. Perhaps this is that moment, a test of whether we can face the unknown without turning it into fear. When 3I Atlas finally emerges from behind the sun, we will have our answer. It will either be gone or waiting. Whatever the outcome, one truth is clear. After this, we will never look at the sky the same way again. Between the silence of the stars and the noise of our own doubts, truth still travels, perhaps already within us.